Corporate secrets are leaking into the ether. Every query sent to a public AI model is a potential breach. The era of blind trust is ending. How can an enterprise harness the explosive power of large language models while keeping its most sensitive, proprietary data completely offline and under total control? Before, data was treated as a disposable commodity, blindly funneled into third-party cloud APIs. Convenience prioritized speed, but at the cost of total data transparency. Enter the bold engineers, a new wave of founders who refuse to accept this trade-off, setting their sights on building a truly localized, zero-trust infrastructure. Armed with deep experience in cybersecurity and open-source development, these developers realized the solution wasn't better cloud contracts, but moving the compute inside the perimeter. The problem was stark. Mainstream interfaces were designed for the public cloud, lacking the necessary hooks for enterprise identity management, audit logging, and data privacy. The breakthrough insight: separate the interface from the cloud. Deploy a local WebUI, self-hosted, that bridges the gap between private LLMs and secure internal workflows. They envisioned a future where companies operate their own private AI brains, an enterprise-grade stack where no data ever leaves the local network's secure reach. The first move was rapid prototyping. They containerized Open WebUI, stripped away public dependencies, and deployed it within a hardened, air-gapped environment for initial testing. It started in a single closet-sized server rack, but it proved the concept. High-performance AI, fully private, accessible, and ready for integration with existing systems. The strategy was simple: swap vendor-locked interfaces for custom open-source frameworks. This allowed full control over user authentication and granular, enterprise-wide data access policies. The challenge was immediate. Local hardware struggled to match the speed and token throughput of massive, multi-billion-dollar public cloud inference clusters. The risk was existential. If the custom AI stack failed during high-demand business hours, the team faced a complete operational blackout and lost trust. They made the critical decision: invest in specialized hardware acceleration and fine-tuned model quantization, prioritizing stability and data sovereignty over pure, unbridled performance. They engineered a zero-trust interface wrapper. Every user interaction was logged, audited, and strictly controlled before reaching the local model. Privacy became a feature, not a byproduct. The real test came with a sensitive legal document processing pipeline. Would the local AI perform without leaking a single byte of trade secrets? Failure loomed as access controls caused a system-wide freeze. Internal data was secure, yes, but it was also entirely inaccessible to the engineering team. The response was relentless debugging. They rebuilt the auth layer from the ground up, ensuring that security never paralyzed the utility of the AI platform. The breakthrough: a stable, lightning-fast stack that processed local queries with high accuracy, zero data leaks, and perfect integration with internal access control systems. This was the turning point. The model was no longer just a project. It was a proven architecture for secure, scalable, enterprise-grade AI production. Suddenly, other firms took notice. The framework expanded, with startups across the tech sector racing to replicate this zero-trust, open-source stack for their own privacy needs. The broader industry shifted. The paradigm of everything to the cloud had been permanently challenged, forcing giants to prioritize private, local inference capabilities for enterprise customers. The lesson is clear: true sovereignty requires owning the stack. The legacy is a blueprint for secure innovation in an age of data-hungry neural networks. In the race for AI dominance, the winners will be those who harness the machine without sacrificing the keys to their own kingdom.